Now we're going to spend just a few minutes to review some fundamentals of the most basic technologies employed in outboards today, two-stroke and four-stroke design. Even though they have their distinct differences, they each offer specific benefits for customers. With the knowledge of the key components of two-stroke and four-stroke technology, you'll be able to better apply an understanding of the innovations that Yamaha has introduced over the years in refining these power systems. Yamaha two-stroke and four-stroke outboards use the same basic principles of any internal combustion engine. Compress atomized fuel within an enclosed cylindrical space, ignite it, and the expanding gas releases a significant amount of energy. Repeat these controlled explosions thousands of times a minute, using the created energy to drive a series of pistons and transform that energy into rotation and torque through a crankshaft. That is the baseline operation of the internal combustion engine. Well, today there are two popular mechanical designs to make that power, two-stroke and four-stroke engines. Both use a variant of an intake, compression, combustion, and exhaust operation cycle. Let's take a look at how they make their power. We'll start with the two-stroke. Now, the term two-stroke means one firing cycle or combustion process is performed for every two strokes, one up, one down, of the piston, or one 360-degree revolution of the crankshaft. Here's what that looks like. In a two-stroke engine, the fuel intake process is called scavenging. As the piston moves downward, the intake or transfer port opens. The air-fuel mixture that's been pressurized in the crankcase passes into the cylinder in exchange with the burned gas to be exhausted from the last combustion. On the compression stroke, the piston moves upward. The scavenging or intake port and exhaust port closes, and the air-fuel mixture is compressed inside the cylinder. As this happens, the crankcase develops negative pressure, a vacuum, that pulls open one-way reed valves to draw in new air-fuel to enter the crankcase to be pressurized and get ready for the next firing cycle. Just before the piston hits top dead center, a spark from a spark plug causes the compressed fuel to ignite. The near instant